Hey y'all, welcome back. Today on my bench I got something a little bit more unique from what I'm used to. This is a T-200 tuner, Harman Kardon. It's called the Guide. It is a, as you can see, tube tuner. This is AM/FM mono. There's no stereo decoder on this one. This was probably produced back before stereo FM was a mainstream thing. But it's a nice little unit. It's tiny, but it's not without its problems. I'll show you a few of them right here. Biggest problem, obviously, it doesn't have a faceplate or a cage case, and it doesn't have a bottom. Somebody has hacked off the power cord, so we'll have to replace that before we do any testing. One of the tubes is cracked, gone to air. You can see it's got that white chalk on top. There's a great big crack in the tube here. And this is a 6AU6, which is a fairly common tube, but I don't have these in stock. So I ordered some 6AU6s. They're Russian replacements. So whenever they get here, we'll replace that. But in the meantime, I'll pull a tube out of one of the other tuners and substitute it in here just for testing. It's nicely laid out. It's got 4, 5, 6, 7 tubes, which is a little better than your All-American 5s that they used to produce in the masses. This is a little more upscale and higher market than those cheap radios. This is an actual tuner. So another problem, just looking off the top of my head here, let's see if we can find any more. I got a cap here that's broken off. I don't know where it's supposed to be soldered to. Another broken cap here. This one's got a chunk taken out of the ceramic. And aside from that, I think that's it. Somebody cut the power cord inside here too. It's cut on the outside, but it's also cut on the inside. So they sure didn't want somebody to use this. And we'll have to figure out where that goes, because we've got one wire here goes to the power switch, and the other wire should go to the transformer, I guess. But I don't see the transformer wire. Where is it? Oh yeah, it's right here on the outlet, courtesy outlet. So let's go through this. I do have a schematic, but it's not great. It's really grainy, and I can't really read any of the voltages or any of the printing. It's got a bad resolution. I'm going to see if I can find a better schematic for this. Yeah, I want to get this going and see what we can do. The only big thing that I don't know about is the power transformer. If the power transformer is burned out, I guess this is a dud, and it's no starter. But we'll see. Let's first put out a power cord and see if we can get that going. And then we'll check out. It's got a selenium rectifier here. Selenium rectifier. And we'll see if that's working. This cap here, this electrolytic. There's only the one electrolytic. And I expect that will be dead, but we'll test that before we power it up. Or maybe we'll go power it up before we test it. It's kind of a unique. Got a switch here. I think that turns off the automatic frequency control when you're tuning. And then there's a power switch here. Power switch, and then it's a, what is it? AM, FM, FM. No, phono input, sorry. Does it have a phono input? Yes, it does. It has a phono input here. And it has an output. That's your signal output. And a courtesy outlet. FM, AM antenna. This phono input. I don't know if it goes through the amplifier or not. I'd have to look at the wiring for this thing, but Discriminator. Okay. Well, we'll get through this. And it's got some alignment procedures here at the bottom. So let's get a power cord on this first and see what we can do with it. Okay, come on, play nice. There we go. Okay, so let's get a power cord on this. I don't know if it's a grounded chassis or not. Somebody put his little autograph down in the bottom here. You can see that. You probably can't. And pencil. There's lots of scribbles around here. This actually, people think this is copper, but it's not. It's actually just, it's a steel. You get a magnet. And it's just copper plated. And that was kind of like Harman Kardon's trademark chassis color for, you know, that era. So let's get rid of this cord. Turn with my iron, it won't heat up. There we go. Okay, and we'll get that replaced. Okay, so I got a new power cord. This one is modern polarized. We'll go with that just for safety reasons. And one thing I noticed on this chassis, looking at the schematic, oh, ripped the schematic already. There's no fusing here whatsoever. No fusing here. So I'm going to add a 1 amp fuse, and I'm going to tack it here, and then I'm going to run the power cord, the hot wire of the power cord up to this fuse, then the switch. From the switch, it's going to go to the power transformer, and the neutral is going to go straight to the power transformer. So that's what we're going to do. And I'll sleeve this and everything so it's all insulated and safe. But we'll put a 1 amp fuse in here just to make this a little more up to date with the safety. There we go. Okay, I've got a new power cord on. I'll show you here. Wired in, the neutral goes straight to the receptacle and then to the power transformer. The hot wire goes straight to this fuse, through the fuse into the power switch, from the power switch back to the power transformer, so everything's good. Let's check, turn this off, let's check for resistance. Guess I should have done this first. Okay, we're open circuit, turn it on. And we got 24 ohms on the primary winding, so that's good. So I think we're doing okay here so far. Next step, I think, is we're going to maybe pull all the tubes and then power it up and see how that electrolytic's doing. What I could do is I could just, well, to test the thing, I'd have to remove all these resistors and wires, and I don't want to do that. So let's power it up on my Variac, and we'll watch the current meter. I don't expect anything to go pop or fry or go over current. If anything, we're going to exceed 1 amp, we're going to pop a fuse, which is no big deal. I can just change it again. But I'm going to pull all the tubes just so that we don't get any anything starting up on us. So let's do that next. Alright, so the power supply for this is very basic. power transformer primary here. We've got two secondary windings. One is for the filaments. It's all the filaments are in parallel, I am assuming. And then there's a selenium rectifier there, and they have something here. It looks like 65 milliamps from what I can see. And then you got your 3 capacitor can electrolytic for filtering. You got your first 40 microfarad, 330 ohm, second 40 microfarad, 330 ohm, and your third 40 microfarad. And this is your clean B plus supply. So it's pretty basic, and there's really nothing that can go wrong with this. They said they don't have any voltages here, so that's the only thing. I can't see any voltages anywhere on this, other than maybe at the tops of the plates of these tubes. This one here, no, that one. It switches through, goes through this coil, and we have 106 volts here. It looks like 105 maybe, 100, 110 maybe, I don't know, 95, I can't read these. So I'm assuming, let's see here, doesn't say anything about what the voltage should be on the power supply. I'm going to see if I can find a better schematic than this. This one's got 120 written on it, plus 120, and that feeds through, that's from the AM. That's the AM, part of the AM tuner. Okay, so anyways, we have our filter cap here and our two 330 ohm resistors underneath these wires. I can't see them very good, but they're there. There's our cap and our resistors. So let's test some of these. Sometimes these resistors, they go open or they go high because there's a lot of current going through them, a lot of heat. So let's test this one. This one comes out at about 320 ohms, which is correct, considering these are 20% resistors. And the other one is right here. Again, it's 320 ohms. See, when you have a resistor like this one, this is, I think that's blue-green orange. That should be 56K. Let's try this one. No, that's blue. That's 6. Maybe that's a gray. Maybe that's 68K. That would make more sense. But it's got a silver band, so it's got 10% tolerance. If it had a gold band, it would be 5% tolerance. And when you have no band, it's 20%. So here is a no band, and this is a 15K resistor. Let's see what it measures. Comes out at 17.25K, which is probably starting to get out of spec, but we'll go through that after. I'm not going to worry too much about the resistor values right now. Let's these resistors are good, and we'll see if we get anything out of this cap. So let's plug it into a variac, and we'll slowly raise it and see what we get for voltages. I'll have to get some voltmeter set up here. Alright, so this purple wire here coming off the bottom of the can, that is our power output. This brown wire here comes from the selenium rectifier from the transformer. So this is our half-wave rectification, and then it goes through 1, 2, 3 capacitors, and then I'm going to test right here on this here. So we should have, I'm going to turn on my variac. Why isn't it working? And turn that on too. And we'll turn this on. Start turning it up. It's a 300 volt scale. I'm at 50 volts now. Getting close to line voltage. And those caps are pretty weak. You see how it slowly is coming up? We're at 140 volts now. 150, that's maximum for those caps. So I'm going to shut this off. So that cap is really tired, and we will replace it with modern caps, but just to prove we got no shorts or anything in the chassis and everything's working. So I think we can put some tubes in, and maybe we can bring it back up and see if this thing produces a signal or not. Okay, when I did the first test on that power cap, filter cap, it seemed to really struggle to come up to voltage, and it seemed like it was consuming some current too, because I could hear the power transformer straining a little bit. Maybe that's part of the selenium rectifier is part of the problem too, but I don't know. What I'm going to do is I got my 300 volt power supply hooked up, and that's the fan noise you can hear. It's really noisy, sorry. And I'm going to feed it voltage, and I'm going to measure this as an ammeter, 300 milliamps, full scale deflection. We're going to see how much current that capacitor is choosing to consume while I power this up. So here I go, I'm going to start raising the voltage. We're 30 volts now. $60 volts, 75, 80, 100, 135. Doesn't seem like we're consuming anything here. Okay, I got the voltage up to 145 volts across that capacitor, or the 3 capacitors, and this is the current that capacitor is consuming. On a 30 milliamp scale, we are probably down around 4 milliamps, and it's dropping. So those capacitors are starting to reform, and I think this first initial test will go good. I don't want to stress those capacitors too much. They're 150 volts. I could take it up to 150 volts. Looks like I could turn it up a little bit more. And you'll see that current starts jumping around. So I'm just going to leave it at the 150 mark and just let that cook for a while and let it settle. I'll keep an eye on the meter, make sure it doesn't climb. The reason I'm doing this is because when I first powered up the chassis and the power supply, that can cap got a little warm, and I was a little bit concerned it might pop and fill the room with smoke, but it seems like it's holding out now, so it should be okay. So here's a look at some of the tubes for you tube aficionados. This is EMC, made in Canada. It's a 12AT7. This one here looks like it's a Marconi, Radio Incorporated Marconi, I think. The 6BA6. Marconi tubes. Marconi's a Canadian company. Another EMC, another 12AT7, and this one goes in here, I think. Tube sockets are nice and tight. That's good. This is Sylvania 6BE6, and it's another made in Canada tube. Looks like this one's been serviced and this tube's been replaced. 6BE6. Where does that go? Right here. This one is a Raytheon. Best in quality. And it's made in 6AU6. So another IF amp. And this little tiny one is a 6AL5. It's an Emerson, made in Great Britain. When renewing, insist on a genuine Dumont Emerson tube. Okay, I'll try that. 6AL6. And then our last tube is a 6AU6. It's broken. This is a Fleetwood tube. Fleetwood. Doesn't say where it's made. But I have a tube that pulled from another tuner. This is a Harman Kardon tube, made in Holland by Amperex. And this is a 6AU6, but I can't read. It's supposed to be a 6AU6, but I can't read the paint is completely worn off. So we'll go with this one. Okay, let's fire this thing up. What I'm going to do is get an amplifier and plug it into the output, and we'll see what kind of noise this thing makes. Alright, I think we're ready to go. I got a realistic STA20, little stereo receiver, and I got input to that. I'm going to plug that into the output. And we are plugged in. Time to turn this beast on.
That have been studied to date suggest that the vaccine should work, but there's one from South Africa that's still an outlier. Wow. It's not entirely clear about that one, but maybe the other ones, the vaccine should provide protection.
This thing works great.
All the more.
Brought to you by the 5-month rule. If I find something in my fridge that's 5 months old, it means that my wife left me 4.5 months ago.
Sounds good.
The Dick family at Cooker, we're so welcoming.
I don't know what station that is. It's really sensitive. It's picking up stuff I normally don't hear. It's quiet too. Especially with all this RFI that's on the bench, my LED lights, you know, there's switch mode power supplies going on. I'm surprised it's so clean. Sounds good. Okay, well, let's try FM. Okay, FM. We got hiss. We got no stations. We've got no antenna either, so let's hook up an antenna and maybe we can get some life out of this. Shut this off for now. Where's the FM? Okay. Now we're getting hum.
Friday.
No FM. Oh well, can't have it all, I guess, but it worked pretty good for AM. It was splendid. Okay, so we got a little bit of work to do. And I haven't even touched those broken capacitors in the back. Let me pull this off. Pull this off. And let's see. See, I got two capacitors here, one here and one here that are disconnected. So let's address that. So as far as I can tell, this capacitor connects to this ground lug. And it looks like there's a spot on this solder here where the wire got pulled away. Maybe it was just tacked on there. I'm just going to reconnect it to that ground. I can't read this schematic. The tube, the numbers on the tube pins aren't readable. They're just smudges. So I can't tell if it's coming off of this pin, this grid, or what. But I believe it's this capacitor right here that I'm looking at. And it says 10K, which would be 10,000 picofarad. And that's a 0.01. So I think if the shoe fits, it must have quit. So let's solder that on. And let's do that right now. Just going to tack it back on again. Why not, eh? Now this other one, it looks like it goes from, it's hard to see. 1, 2, 3 is ground, 4. Looks like it goes from pin 4 to ground. So what I might do is I might just remove that capacitor altogether and replace it because it's broken. There's a big chunk taken out. Somebody got hungry and it had a bite. But yeah, I'll just replace this capacitor altogether. This capacitor here, what tube is this? This is a 6BE6. 6BE6. This one down here, pin 4. Yeah, I think it's this one that goes to ground. This one shunts the signal to ground. But that's part of the AM. Okay, well it worked with that off. So let's try something. Let's turn it on AM and see how it sounds when I touch this. Okay. Turn on my amplifier. Turn this on. Now it's not going to work.
Is at 651 last count.
We see larger job losses this month, especially in customer-facing industries.
Restaurants, bar, hotels are again underperforming and seeing losses, but a lot of other sectors that actually can be working from home are actually doing relatively well in terms of employment.
Okay, so I'm going to touch this capacitor.
It's 5 industries in Alberta where the employment level is now back.
I don't hear any difference.
February.
Despite the losses, Alberta's unemployment rate remained relatively
So
steady at 11%.
I'll replace that capacitor and we'll button this up. Alright, so I replaced those two caps, or fixed them up. I got two caps are done. Trying to look at what we can do for this FM tuner. We have a 12 AT7 tube up here that's doing dual duty. It's FM RF amp and it's an FM mixer. And then we have a 2 AT7 down here, and I'm not exactly sure what this is doing. This might be the oscillator. It's in the FM circuit as far as I can see. So what I want to do is I want to take this tube and swap it with this tube and see if there's any. I don't have a tube tester here. Never did, and it'd be nice to have one, but I just don't. I never did get a tube tester in my journeys. So this is what we do, and we don't have tube testers. We swap tubes around and see if they work. So let's see if swapping these two tubes makes any difference. Plugging it in. Got my amp on. Okay. Turn this on. And wait for it to warm up.
Was that not just something that happened, but that the executive.
AM still working, so we know those two tubes are good because when we swapped them both out. So let's turn it to FM. I hear a weak signal. There's AC/DC. It's very weak. But then I have no antenna. It's a lot of distortion.
We see the person who was working on
So FM does work. Interesting. We are consuming 27 watts from the outlet. What happens when I connect an antenna? Does not like that.
Voilà, rencontre. Not too cold.
So it's working. It's got some distortion. So I think an alignment will clean that up. I'm just wondering why this it doesn't like an external antenna. Whenever I attach it, I get that 60 hertz hum. I know I got a lot of noise here. Let's just turn some things off maybe. Yeah, it's picking up a lot of interference.
sit in here.
it's doing well. Replace a bulb. Oh, that wire's broken. Okay. I'll get flagged. Get this old wire off before I solder it. I don't like leaving old wire, like clipping it and leaving a connection, because it's just shoddy workmanship, I think. Remove this little piece of wire. There we go. And we will
down the government gates.
You hear that distortion? That
on air, online, and on your smart speaker.
You are inside 9.
I think it just needs an alignment, to tell you the truth. And some lubrication.
That he is on the verge of working with another platform, Twitter. And then...
My name is Maria Elena.
That they were strongest.
I'm going to have to lubricate all of this string, well, not the string, but the pulleys, the main tuning gang. I think it all needs, it's so dry, and so we'll go through that and then we'll do an alignment, and I think we're going to be done with this. Looks like it's good. Alright, I think I'm going to leave it at this for now. What I'm going to do is I have, like I said, I had a replacement tube coming in for this cracked one that's burned out. It's not burned out, it's cracked and gone to air. So what I'm going to do is I'm going to wait for those tubes to come in, and then when they do, I'm going to do a full alignment on the AM and FM, because I don't think it's right to do the alignment before I replace the tube, because you know, once you swap tubes out, you probably want to tweak it. But I'll do that. I'll put this on the shelf for now, and this is as far as I'm going to take it. I cleaned it up a little bit. I don't know if you can see any better, a little bit of a difference between the dust is gone now. But I'm going to leave this cap alone. It seems to be working. It's functioning as intended. It hasn't failed yet. I don't know what the capacitance is on it. It's supposed to be a 40-40-40 at 150 volts. but when I put the power to it, it didn't seem to be consuming any leakage current, and it sort of reformed itself, so I'm going to leave that alone. I did some lubrication on the dial string pulleys and the main tuning cap. I lubricated the bearings, and it really smoothed it right out. It doesn't feel so dry and crunchy anymore, and it's nice. It's got a nice action to it. So I'm going to leave this alone right now, put it on the shelf, and when the tube comes in, we're going to continue on with a alignment. Alright, so I just finished wrapping up the last segment with this, and then a couple days later my Russian tubes came in. Pretty cool, huh? These are clone, what are they? They're clone 6AU6s, and I got 4 of them. I didn't need 4 of them, but then it's a good thing I got 4 of them, because I have another tuner that came in and the whole tube complement was missing, so I have to source all the new tubes for it. But this is what is this? You can read that on the glass. It's written 6, and then it's got a couple of Russian characters and a 4. But this should do the business. Now, one thing when you're playing around with these Russian tubes is you have to pull out the data sheets for both the originals and the Russian ones and compare them, make sure that the pinouts are the same, make sure that they're compatible. But I'm going to try this one out, and we'll see how it goes. And the buggered one. Okay, plugged in, turned on. We're going to try it. Let it warm up. And I don't... Oh yeah, I see filament. It's working on AM.
Goes back 3 decades for 30 years.
Of Canada's
AM's working. AM's working pretty good.
Policy. Ranchers, First Nations groups, Anglo...
The AM band's pretty quiet where I live. I think we used to have a number of stations that's down to about 4 local stations now. It's not as hot as it used to be decades ago, but that's okay. It's good because it's a quiet band, and I can pick up a lot of DX. I can pick up stations from cities that are a couple hundred miles away. And,
Environmental rules.
it's good for testing. Okay, let's go to FM. And I need an antenna, if I remember correctly. And we're getting noise. I'll shut the lights off.
Johnny.
Oh! Let's go! 500 off selecting models.
It's working.
It's our 14th Street Northwest.
That one there is our local station to this town, and it comes in the strongest out of all of the other ones, which is showing up here as well. But you know, I got a few weak FM stations, so we're going to give this thing an alignment. There's some alignment procedures here on the bottom of the page. We're going to go through and do the AM. It's pretty basic. It's IF alignment, and then we do the band spread and adjustment, and then the same thing for the FM. There's 3 FM transformers that need adjusting on the IF discriminator, and a few other ones. So we're going to go through this and do this, and then I'll get back to you on that. Alright, so I went through the whole process of doing alignment on this thing, and then I had the video segments, went through. I was doing the rendering of the video and editing and piecing everything together, getting the video ready to publish, and I realized I made a huge mistake. So I had to scrap about, I don't know, 20-30 minutes of video of how I did an alignment on this thing, and before I realized my screw up. And it was a pretty big screw up too. It was a pretty amateurish thing to do, and I'll show you exactly what I did. If you look at this schematic and look at the IF transformers, here, let me get this in focus for you. If you look at the IF transformers, you'll notice that each can is in these dashed lines, has 2 coils, and these are actually tank circuits, but they're transformers. They're magnetically coupled to transfer primary, secondary, and then they have the capacitor and the coil to provide a tank, so you can tune it to a resonant frequency. But if you look, you'll see that each coil has its own adjustment, denoted by this little arrow. If there was one adjustment for both coils, there would be one arrow through both of them. But since there's 2 arrows on one in each coil, that means there's 2 adjustments in the can. So what I did is I went through and I did all the adjustments from the top. Oh yeah, it looked really good. Nice signal coming through. And I completely forgot or ignored, or whatever you want to call it, I did not adjust anything on the bottom because I was oblivious to those tuning adjustments. So what I have to do is I have to do it all over again. I couldn't really publish that video because it was incorrect information. I don't want to put people astray. I do my best to get accurate information to you guys, so I had to throw all that video away and start over. So here we are again. We're going to start over. I got it all hooked up to the generator and the scope, and we're going to do the AM and FM alignment again. And this time we're going to adjust the top and bottom coils of each can. So right now it's hooked up for AM. The tuner's powered on and warmed up. I'm going to feed it a 455 kilohertz signal and turn the signal generator on. And you can hear it on the amplifier. It's coming through, and you see a little bit on the scope. Let me turn up the amplitude. And you can see that all that hash on the signal on the scope is noise from my bench, like switching power supplies and stuff. So just ignore that. It's not part of the radio fault. So for AM, our first step is we have feed it for the 455 kilohertz signal at 30% modulation. We're going to feed it into the pin 7 of the tube BE6, and then we're going to scope the output. And we're going to adjust the 2 AM IF cans for maximum output. So I've got the signal generator connected to ground, and I'm feeding it through a, I think it's a, what is that? It's a 0.1 microfarad capacitor. I'm just feeding it through just to provide DC blocking for my signal generator, because I don't want to backfeed 100 volts DC back into my signal generator and blow it up. So we have to find the 2 IF cans for AM. And if I look, I got one here and one here. So let's see if we can do these from the top. Okay, that's decreasing. Let's turn it the other way. Right there is about the peak. Oh, there we go. I detuned these a little bit just to show that what the adjustments can do. Okay, so we need to get this one from the bottom. It's going down. Let's go the other way. Down. That one was pretty close. It's peaking right about there. The other one is here. And that's peaked there. So what I'll do is I'll run through them one more time just to make sure. I'll turn down the signal generator a little bit. No, actually, it'd be easier if I do this, I think. Be able to see the amplitude better. Let's turn down the signal. Make it a little weaker. Feed it a minus 60 dBm signal. So let's try this one more time. We'll get it maxed out. Refresh rate's a little too slow on the scope. I think I had it pretty close. Right there, I think is... Let's try this one. That one got a little better. Right there, I think. That's maximum right there, I think. Well, let's see. Let's see if we can do a little better. No, I think that's about it. Okay. Shut that off. So we'll get set up for the next test and this next alignment. Okay, for this next alignment, I'm going to be adjusting the trimmers on the tuning gang. And I just want to point out a few things about these tuning gangs. If you look at this one, there's actually four capacitors, four variable capacitors in one tuning gang. So you got one here, you got one here, one here, and one here. And now you're going to notice there's a little bit of difference between this one, and then these two. These ones have more plates and they're closer together, so this is a higher capacitance, like more picofarads, and these ones, there's less plates and they're spaced farther apart, so it's a lower capacitance and lower picofarads. These two are for the AM band, and these two will be for the FM band, just because of their design and their capacitance. So if you look at, considering there's four capacitors here, there's also trimmer capacitors on top, and there's usually 4 screws, but in this case there's only 3. So this screw is a trimmer capacitor for this gang here, or this capacitor part of the gang. This trimmer screw is for this capacitor, and this trimmer is for this capacitor. This is missing a screw. There's no trimmer here, but the trimmer for this capacitor is underneath the chassis, so you have to keep aware of that. So when you're going through alignment procedure and they tell you to adjust the AM, we'll see if I can get this here. It says oscillator and antenna trimmers right there where my finger is. That's these two here, because one capacitor will be for the the oscillator, and one will be for antenna trimming. So yeah, I'll show you here on the diagram. If you look here in the AM section, you can see one capacitor here. That's the antenna trimmer, because this is a tank circuit, and we want to tune this to work at AM frequencies. And this trimmer here, this capacitor, is for this tank circuit, and this actually tunes the oscillator. And it doesn't show it on the schematic, but there's actually, for these two capacitors, there's two trimmers as well. So there's two capacitors and two trimmers. They're all put on the same tuning thing. So let's.
This was after he had disbanded that non-partisan arm's length committee created by the previous conservative government.
Let me get the camera set up and we'll go through the procedure. Okay, so the next step in the AM alignment is I set the signal generator to 1500 kilocycles at 30% modulation, and then I tune the oscillator antenna trimmers and the oscillator trimmer and antenna trimmers, which are these two on top. Now there's no mark on here for 1500 kilocycles. There's one for 1400 and one for 1650. I could put it to 1650 or 1400 and then set my generator to the same frequency, which I think I'll do. I'll do 1650 because the purpose of that is to get this tuning indicator aligned with the signal generator, so that when a station is at 1200, for example, if I tune it to 1200, it should be the station right there, not 1250 or wherever, you know. So it actually gives accuracy to the dial. So I'll tune this to 1650. I'll turn my generator to 1650. And we'll turn on the signal generator. Get a little bit of signal. I got minus 60 dBm. Let me turn this up a little. Minus 50. And we'll see. Yeah, we're off a little bit. You see it there when I turn it. Probably around 1670, 1680. So let's turn this back to 1650, and then we'll adjust the two oscillators. One's the oscillator, I think it's the smaller one. I'm going to tune this to maximum. Let me turn this down. Turn this down. Okay. Tune this to maximum. And I lost it. Too far. Very touchy. Right there, I think. Yeah, it's bang on. Now we're going to trim the antenna for the same frequency. Other way. Go up. Right there, I think is peak. So what we did is we peaked out both those, and that aligns the dial pointer with 1650 kilocycles, and we peaked out the antenna trimmers so that they get maximum efficiency at that frequency and get the maximum signal. The last step in the AM alignment is to tune the signal generator to 600 kilocycles, 30% modulation, and we're going to adjust the oscillator coil. And the oscillator coil is hidden beside the 6BE6 tube. It would actually be this coil here on the schematic. This coil is in parallel with the oscillator tuning capacitor, the one I just adjusted. But we're going to do it at the bottom of the band.
Maybe. Okay.
We're going to do it at 600. I'm going to set this to 600. I'm going to set my signal generator to 600. Turn down the amplitude a bit. We're at minus 75 dBm, so this is starting to get a real sensitive tuner now. And we can adjust this oscillator coil. Right there, it's about the best it's going to get. And we're done. Shut that off.
Way to plan your estate. Spend less time with your accountant, lawyer, and banker. Paul Lindsay from Macmillan.
So now we have a very sensitive tuner. Selective and sensitive.
Take a top. $2.06.
Thank you. .com.
Okay, let's go move on to FM. Alright, so we're going to move on to the FM, and the first step is to do the RF adjustments. So I'm going to be feeding a 10.7 megacycle modulated frequency, and I'm going to be putting that at pin 2 of the 12AT7. Pin 2 of the 12AT7 is right there. I've figured it out because there's two tubes, two AT7s. So got that figured out. And then I tacked in a DC blocking capacitor. Find a place in the band where there's no stations. Just where it's really quiet. And then I got 3 IF transformers. Point them out to you here. I can move this without disturbing anything. One, two, three. So let's turn on the signal. Turn it up. Let me find a different spot. Okay, I got minus 40 dBm. And be able to see it on the scope and start tuning. The first one. Very dull peaks on these coils. There we go. do the bottoms. I could do the top and bottom, top and bottom, top and bottom, but I'm going to do all the tops first, and then we'll go move on to the bottoms. Something's shorting out here. Hang on. What is shorting out? Okay, I don't know if you can see this, but right here, this resistor lead is touching that, or one of the leads for the IF cans. So I'm just going to move it away from. Try and move it away from the. There we go. I suppose if I shut it off, I could probably get some metallic tools in there, but bend that away. There we go. We need to be able to get this into the. Not much room here. There we go. I think we're good. Okay, we're back on track. Let's get this. There's not much room for the tool to get in there. I gotta be careful because I already broke this once and I re-epoxied it. And it's holding out. I just don't want it breaking again. This one is really tight and can't get it in there. I might have to try a metal. I'm gonna try a metal screwdriver. This one might be too big. There we go. Actually, there's no improvement there. That was already bang on. Okay, so we have 2 more to do. That one's okay. Last one. That one. Turn this one way in and back it out slowly. Getting distortion on this one. Let's try the top. No, that's it. Go through the tops one more time. Okay, I think that's all we're going to get out of that. Wasn't much of an improvement. On to the next step. Okay, next step. We are going to do the discriminator. So same signal, 10.7 megahertz, in at the same spot. Pin 2 of the 12AT7. And we're going to scope on B, which is the B is right here, which is on the output line, so I can move this probe to B. And we are going to adjust the discriminator for maximum gain and symmetry. The discriminator is the last can here on the back side of the FM. So let's turn up the volume here a little bit. That's looking better. Okay, let's do the other one. This is frozen. Try this here. It's really deep in there. Does not want to go. I think I got it with the steel. Okay, so let's turn this down. Last steps is to set the dial indicators. So we're going to do it first at 106 megacycles, and we're going to tap our signal off at point A, which is down here between the IF can and this little RC circuit. And we're going to trim the oscillator and antenna trimmers for maximum output. So let's do that now. Inject our signal in at the front end, so we're not doing IF anymore. So I'll put these on the input for the FM antenna. Let's go with shut this off.
Let me.
We'll do this at a part of the band where there's no station. The AFC wants to kick in and there's really no spot here other than I'll do 107 megahertz. That's the only spot where there's no stations. Okay. Problem is the AFC wants to lock in on the station. When I push the tuning knob in, it defeats the AFC, and I can tune the station in. When I release the button, it locks in. See how that works? So what I want to do is I think I want to defeat that AFC while I do this last step. So just hang on. What I want to do is ground that. And that keeps the AFC off. Now I can tune it in normally. So I'm going to set this to 107. And we're going to do the trimmer. Trimmer's right here beside the tube. Now we're going to trim the antenna. It's about as good as it's going to get. And we're tuned at right at 107 megahertz. So they're going to do the same thing at 90 megahertz. Megahertz. This coil here is your oscillator coil. And see, I can bring it in by pinching the coil together. I want to get that as close to 90 megahertz as I can. It's very close. I want to get it right there, but I'm not far off now. It's going to massage the coil windings closer together. It's just a little bit off. Very, very close. There's that sweet spot there is just a little bit. I think that's going to have to do right there. And then we're done.
Et j'ai découvert la musique en même temps que tout le monde avec les musiciens du nouvel ensemble moderne.
Let's get an antenna. See how this thing performs. And here's a quick look at the power supply. Scoping the output of this line here after it comes out of the rectifier and goes through three stages of filtering. It's 120 volts DC, and I have 120 hertz ripple on it, and it's the scope set for 200 millivolts division, so we're getting roughly probably 4 maybe 500 millivolts of ripple on a 120 volt power supply. So it's really not that bad. It's just that capacitor is probably weak, and it probably could be changed if this were to come out clean. If you want, I could scope each point here. I'm scoping the output. I could scope the middle capacitor, so let's do that right now. Scoping the middle capacitor, and we still have, we got 1 volt per division, so we got about 2 volts of ripple. And if I scope on the input, just between this rectifier and the cap, if I scope that point, we'll even get more. And that's 5 volts of division. So we got about 12 or 13 volts of ripple on that. So it's down to about 500 millivolts on the output of that. It could probably be better with brand new capacitor. It would probably be closer to 0. The stronger signals don't have any 60 cycle hum, so I'm beginning to think maybe it's interference. But we could scope the power supply and find out for sure. I'm pretty sure it's clean. So that's it for this tuner. I think the one thing I didn't mention, I don't think, is dealing with tube equipment like this, these tube tuners. You have to let them run for about 15-20 minutes before they go and stabilize. Everything has to stabilize, and before the circuits are tuned or adjusted. So that's kind of important. A lot of temperature sensitive components in here, and the tubes really don't wake up until after they've been on for like 20 minutes, and then they start to develop into they start to settle into their characteristics. So That's important to keep in mind if you're working on tube gear.
Set yourself up ahead of other guys, and if not for the injury to...
The game works great.
Who are the people on the ground? Who are the black?
It's full blast and there's very little background noise.
So they killed Keystone and rejoined the Paris.
Baby steps. Baby.
Now we're getting some interference above 1 megahertz.
Transport.
Yeah. Very good.
But like to me, like those guys.
Very good. All right. That's it for this one. Thanks for watching.